Hello everyone, welcome to YourPedia Education. So today we are going to discuss one topic, that is matrix, right? It is really important for airport authority exam. If I come to the past exams, mostly questions I am asking, I'm talking about this matrix, mostly 2 or 3 questions you can expect from this one. Either it is directly from the matrix, either they are from the determinant or like that, right? They are related to the matrix, right? So basically, if I'm talking about, this is the most important topic for your airport authority. Okay, let's start with what is a matrix, right? The first question when we studied a matrix, that will come into the mind, that what is a matrix, right? Matrix is a rectangular arrangement. This is a rectangular arrangement of real or complex number. Let us take, this is a rectangular arrangement. It means it will have the element which are in the form of rectangle. The first element will represent A11, A12, and last element is, let us take A1n. So it means second row. These things I'm just writing first. A21, A22 up to A2n. Similarly, A M1, A M2 up to A Mn. So this is the matrix representation, right? Inside this one, there are the first thing, this one, and this one. These are the rows. So this type, this is represent the first row. This is represents the second row, and this is represents the mth row. So there are m rows, right? And basically this represents the columns. This is represents the first column, second column, and this represents the nth column. So basically, inside your matrix, whenever you represent a matrix, that will be the arrangement in the form of rows and columns, right? These are the rows and these are the columns. So inside this matrix, inside this representation which I am showing you here, that is having n number of columns and m number of rows. So generally, when we are defining a matrix, we generally define its order. Order is represented by m cross n. So the first thing inside that order represents the number of rows inside your matrix. So inside this matrix there are m rows, and the second term represents the number of columns. So inside this matrix we will have n columns, and this is you can say the rectangular representation, and this is represents a matrix A. So this matrix A, the second representation, this matrix A can also be represented as Aij, which is having m cross n. That means that this is a matrix of m cross n, right, which is having m number of rows, n number of columns, and its elements are A, I, J. Ij represents I. This I represents the number, that represents the position of, you can say that if I am calculating the first element of first row and first column, we are calculating the first element of first row and first column, then this first this first I represents the row value, J represents the column value, right? If you are representing Aij, if you want to calculate the first element, then I will be 1, J will be 1, right? So the first position represents the row, second position represents the column, right? And this I is varied from 1 to m, and this J is varied from 1 to n. Let us take an example. Let's take, I defined a matrix A that is represented by Aij, and that is 3 cross 3, right? And I tell you that this Aij follow this property, that I square minus J square. this Aij follow this property I square minus j square, or let us take little bit easy, that is I minus j. And I want to draw the matrix for this one. How we can draw it? So this matrix A can be represented by, when you replace this first element, when you are calculating the first element, that's the meaning of this first element. This represents the first row and first column. So I and j both are equal, so that means this element represents the 0. Now move to the second element. At this second element, what will be the value of I? I is still remain 1, j become 2. So when you put I equals to 1, j equals to 2, this element become minus 1, right? Next, move to the next element. At next element, I again represent 1, j is become 3. When you put 3 here and 1 here, that represents minus 2. So we go to the first row. Now move to the second row. When we move to the second row, the I become 2, and we calculate the first element, 2 minus 1, that is 1. When you go for the second element, I or j both are 2, then it is going to be 0. When you replace I is equals to 2 and j is equals to 3, that means this is minus 1. This is going to be 3 this time. 3 minus 1, that is 2. 3 minus 2, that is 1. 3 minus 3, that is 0. So this is the matrix rectangular form representation. This is called element wise representation. So you can represent a matrix either in this form or either in this form, right? And here we define that Aij is following some certain type of property, like we defined here in this question, that I and j follow, Aij follow that Aij is equals to I minus j. So these are the two matrix representation differently, where first one is rectangular form representation, that second one is the using the property of the matrix element, right? So compact form of above matrix represents Aij, right? Aij m cross n, and A is equals to Aij, right? Element of the matrix, the numbers A11, A22 in the above matrix are known as the element of a matrix, generally represents Aij, which denotes the element in the row and jth column, right? Order of the matrix, I already discussed these things with you. So whenever I define that a matrix has order m cross n is equals to 2 cross 3, it means that is having 2 number of rows and 3 number of columns, right? Okay, one more thing you have to understand here. Let us take, we define a square matrix. In square matrix, m and m cross m, right? Or n cross n, you can say. The number of rows and number of columns are same. Let us take an example 1, 2, 2, 1. So this is a square matrix because inside this one length and width are same, means number of rows and number of columns are same. That's why it is called as square matrix, right? And other one, if you have 2 cross 3 or 3 cross 2, that is a rectangular matrix, right? So that is the difference between square matrix and rectangular matrix. Whenever we are talking about a square matrix, then inside the square matrix the number of rows and number of columns are same. Inside the rectangular matrix, the number of rows and number of columns are different. See, inside the airport authority exam, this type of question he may definitely ask. Sometimes he give you the property of a matrix and he will ask you that draw that matrix here, right? Next thing, the types of matrices. How many types of matrices are available there, right? The first one is row matrix. Row matrix means there is only one row and there is any number of columns inside that one. Let us take, I defined a matrix A that is having 1, 2, 3 elements, right? So basically this is a row matrix because it is having one row and 3 columns. So this is represents a row matrix. Row matrix means that is having only single row and it can take any number of columns. So that is represents the row matrix, right? Next type of matrix is column matrix. Inside the column matrix, that is having only one column. So basically if I have a matrix, that is a column matrix that is having 1, 2, 3 these elements. So what we are seeing, this matrix has only one column and 3 rows. So we can represent this matrix 3 cross 1. So generally, if I'm talking about a row matrix, the row matrix generally represented as like A is equals to Aij, right? I is equals to 1 and j can vary from 1 to n, right? J can vary from 1 to n. That is the representation of a row matrix. So inside the row matrix, generally he gives this information and asks you that which matrix is a row matrix, which matrix is a column matrix. So if I come to this column matrix, inside the column matrix, what is happen? We can represent a matrix A is equals to Aij, where I can vary from 0 to m and j can also equals to 1, which is having only one column. That is a column matrix, rectangular matrix. Rectangular matrix, yeah, this is the rectangular matrix. I think I already discussed this thing with you. A matrix with order m cross n, where m does not equals to n. Let us say you have a matrix that is having 3 cross 2 order. This is also a rectangular matrix. If I have a matrix that is having 5 cross 2 order, that is also a rectangular matrix. So inside the rectangular matrix, this first term and the second term will not be equal to each other. That is called as rectangular matrix, right? Next one is horizontal matrix, right? Horizontal matrix means a matrix in which the number of rows are less than the number of columns. Let's take 1, 2, 3, 4, 5, 6. So inside this one we have 2 rows and 3 columns. So this matrix is generally called as horizontal matrix. Horizontal matrix means which is in the form of horizontal matrix, right? In the form of horizontal form, right? Next one is vertical matrix. Inside the vertical matrix, the number of rows are greater than the number of columns. Let us take, we have 1, 2, 3, 4, 5 and 6. This is a matrix having 3 rows and 2 columns. So this matrix represents a vertical matrix. Null or zero matrix. A matrix of any order having all its elements to be 0. That is called as null or zero matrix. So if I represent, let us take, I have 2 cross 2, then we can represent all the elements 0. So this is 2 cross 2. So basically we represent by O and we write the order 2 cross 2. So that means this represents a null matrix of order 2 cross 2 or zero matrix of order 2 cross 2. What is the meaning? That you have to make a matrix which is having 4 elements, that all elements are 0. Right? And this is the other representation for that one, that Aij equals to 0 for all values of I and j. Square matrix, I already discussed this thing with you. Whenever you have a matrix in which the m is equals to n, that is called as square matrix. Let us take, you have a 2 cross 2 matrix, 1, 2, 3, 4. So this matrix is a square matrix because inside this matrix the number of rows are equals to the number of columns, right? Next is diagonal matrix. That is important. Diagonal matrix. When we are talking about the diagonal matrix is only defined for a square matrix. So inside the diagonal matrix, what is happen? All the diagonal elements are non-zero. A11, A12, oh sorry, A22, A33. Let's take it as a 3 cross 3. And rest all the elements are 0. So this matrix is called as diagonal matrix. So basically diagonal matrix, leading diagonal elements are, except the leading diagonal elements, all the elements are 0. So Aij is equals to 0 when your I and j does not equals to 0. And other representation for this diagonal matrix is that A is a diagonal matrix which is having A11, A12, A13. These are the diagonal elements. So let us take, I represent a diagonal matrix that is having element 1, 2 and 3. So what is the meaning of this one? That it is a diagonal matrix of 3 cross 3 which is having all the diagonal elements are equals to 1, 2, 3 and rest all the elements are 0. So this is your diagonal matrix of 3 cross 3. So this is the another representation, and this is the matrix representation for this one. Next one is scalar matrix, a square matrix in which every non-diagonal elements is 0 and all the diagonal elements are equal. So basically, if you go to the previous one, in the previous one where we defined as a diagonal matrix, inside the diagonal matrix, all the diagonal elements are non-zero. But inside this scalar matrix, what we are seeing, that diagonal elements are non-zero, but the diagonal elements should be equal to each other. So we will have 2, 0, 0, 0, 2, 0, then 0, 0, 2. This is your scalar matrix, right? So what do you mean by the scalar matrix? That all the diagonal elements are non-zero and all the elements will be equals to each other. So whenever we define a diagonal matrix, the diagonal matrix is defined as which is having all the diagonal elements are non-zero. There is no condition that diagonal elements are equal. And when we come to the scalar matrix, inside this scalar matrix, your diagonal elements are non-zero and these diagonal elements should be equals to each other. Next one is identity matrix. Identity matrix is Aij is equals to 0 if I does not equals to j, 1 if I is equals to j. So basically, if we talk about the identity matrix generally represented by I, and it is having diagonal elements are equals to 1. So what we can say, this identity matrix is a scalar matrix. This identity matrix is a diagonal matrix, but every diagonal matrix cannot be identity, and every scalar matrix cannot be identity, but every identity matrix is a scalar matrix as well as a diagonal matrix. If I am come to the scalar matrix, every scalar matrix is a diagonal matrix, but every diagonal matrix cannot be a scalar matrix like that, right? Okay. Next thing is upper triangular matrix or upper triangular matrix, right? For a square matrix, A is equals to Aij n cross n is called to be upper triangular matrix if, try to understand here. Let us take, I have 2, 3, 0, 4, 2, 0, 0, 3. So inside every matrix there are two triangles. One is upper triangle, another one is lower triangle. This one is a lower triangle and this one is a upper triangle. So inside every matrix there are two types of triangle, upper triangle and lower triangle. When we are talking about a upper triangular matrix, the upper triangular matrix is a matrix in which all the upper triangular elements may be non-zero. All, I am not talking about that one, that all the elements should be non-zero. Maybe there is 0, but there is all the elements below this one. Means you can say for the lower triangular matrix, lower triangle, all the elements should be 0. If you are writing it like this, then Aij equals to 0 when your I means number of rows are greater than the number, whenever the row number is greater than the column number, like that. Because at this point we can represent this A21, this represents A31, A32. So the row number is greater than the column number. So whenever you are defining a row matrix, upper triangular matrix, then your lower triangular should be 0. Its mean is not like that this upper triangular is always non-zero, right? Means all the elements of upper triangle non-zero. This is also upper triangular matrix, right? Because its lower triangular is completely 0. Inside the upper triangle there is only one element which is 0. So that is the definition of upper triangular matrix. Why we are defining that one? Because loads of property of your matrix determinant depend on these things. You can directly find that one. Lower triangular matrix, right? Lower triangular matrix. A square matrix A is equals to Aij n cross n is called as a lower triangular matrix when Aij and this time opposite. When your J is greater than I, it means your upper triangle should be 0 and lower triangle may be anything like this. But your upper triangle, this upper triangle is 0. So that's why it is called as a lower triangular matrix. Now you understood what is the difference between upper triangular and lower triangular matrix. See, sometime he may ask in the exam, in airport authority exam, he give you a property that you have a lower triangular or upper triangular matrix and find its determinant. So remember, whenever you have a lower triangular or upper triangular matrix and you are calculating its determinant is always equals to the product of its diagonal elements, like that. So this type of question he asked in your airport authority exam, right? Next is submatrix. Submatrix which is obtained by given matrix by deleting any number of rows and columns or both. Let us take an example. We will have a matrix 2, 3, 4, 8, 9, 7, 3, 2. This is a matrix A and we are writing its submatrices. So its submatrix is like that. I delete A1. Let us writing A1. 1, 4, 7. This is a submatrix. I delete 2 columns from there, right? A2 is equals to like that. I am writing 8, 9, 3, 2. This is also a submatrix because I delete this first row and first column, then we will left with. So any matrix which can be made from this A matrix by deleting some rows, columns or both. It is not like that if you remove one column also, 2 columns, then only it will represent a submatrix. You can delete any number of rows and column, you will left with a submatrix. If I go for A3, if I have only this single element, this 2 only here, that is also its submatrix because we delete the first column, second column, first row, second row, we will left with this element 2. So this is also a submatrix of a given matrix, right? Equal matrices, right? That is important. Equal matrices. So whenever we are talking about the equal matrices, two matrices A and B are said to be equal matrix. The first condition, their order should be same. Let us take, you have a first matrix that is having M cross N. Let us take, we have A matrix M cross N, or not M cross N. Let's take an example here. Let's take, we have a matrix 1, 2, 2, 1. That is 2 cross 2. And we are trying to add this matrix 1, 2, 3, 4, 5, 6. Yeah, this is having 3 cross 2 matrix. So this addition is not defined. Right? To define this addition of two matrices, their number of rows equals to the number of rows of first column, or you can say the order of these two matrices must be same. It means if you are adding two matrices, one matrix is M cross N, then the matrix B should also be the same order. Then only your matrix addition is possible. And when your matrix, the first condition you have checked that the order of these two matrices is same, then what you have to do? You have to go for the second thing, how we can add them together. So the addition of two matrices can take place by doing the addition of each element with the other matrix, each element, right? Right, okay. Yeah, here we are talking about the equal matrices. When you are comparing that two matrices are equal, not addition, sorry, not addition. We are comparing with equal matrices. These two matrices only equal when their order is same, but there is no order, we can't compare. If order is same, sorry, when order is same, then then you have to check that all the elements should be same, right? Let's take again 1 2 2 1. Then only you can compare. Then only you can compare. That is become 1 2 2 1. These two matrices may be same. These two matrices will be same if they have the same number of rows and same number of columns. Then we can map this one with one, this two with two, then we compare this two with two, this one with one. So if you have two equal matrices, so first what is the order of two matrices should be same, right? When your order of two matrices is same, then you have to compare each element with the other element of the second matrix, right? Each element by element comparison. If each elements are same, then we can say two matrices are equal matrices, right? Principal diagonal of a matrix. See, basically inside any rectangle or square there are two diagonals. This is first diagonal, this is second diagonal, right? Whenever we are talking about a square or rectangle, there are only I'm talking about here is a square matrix, not for the rectangular matrix. We generally define the principal diagonals for a square matrix, right? So basically inside any matrix there are two types of diagonal possible. This is called as principal diagonal, main diagonal, principal diagonal or main diagonal. So inside this matrix, inside any square matrix, this diagonal is called as main diagonal or principal diagonal. So principal diagonal is of A is 1 6 1 6 and 2. So that is called as principal diagonal of a square matrix. Singular matrix, yeah, that will be better understand when we studied about determinant, right? So basically a singular matrix is a matrix, a square matrix A is said to be singular matrix when its determinant is going to be 0. Whenever your determinant is 0, then it is a singular matrix, otherwise it is a non-singular matrix. Now we are come to the algebra of matrices. Now the concept of addition will come. Sorry, I am discussing that one there. I think that is addition. I forgot that. That is we are comparing two matrices. That is equal matrices. Okay. Addition of two matrices. Whenever you are performing the addition, right? Again, the first thing, the order of two matrices. When you are performing the addition, order of the two matrices should be same. Whenever your order is same, this is B matrix. Whenever your order is same, then we have to add them together, right? And addition will be performed element by element. Let's take, we have 1 2 3 4. This is a 2 cross 2 matrix, and we have a B matrix that is having 4 3 2 1, right? This is also 2 cross 2, right? Okay, before taking its 2 cross 2, let's take, you have B matrix that is having 2 cross 1. So in this case, the first matrix have the order 2 cross 2, the second matrix has the order of 2 cross 1. Then whenever you perform the addition is not possible. Don't add this, that first add this 4 with 1, then 4 this 2 with this 3, then 4 with this 2, right? That option is also given in the exam. But remember, because this matrix order and this matrix order are different, so their addition is not possible. Their addition is not possible. Addition is only possible whenever you have two matrices that are having the same order. Let us take 1 2 3 4 and the B matrix that is having 2 4 6 8. And you are performing A plus B, the addition of these two matrices. The addition of these two matrices can be done by adding element by element. 1 plus 2 that is 3, 2 plus 4 that is 6, 3 plus 6 that is 9, 4 plus 8 that is 12. So the A plus B is given by this one, right? That is A plus B, the addition of these two matrices. Now properties of addition. These are the property of addition, right? Whenever you have three matrices A, B, C, remember the order of these three matrices is same, M cross N, right? We are having the three matrices A, B and C which are having the same order. Now the first property, commutative law. They are always follow the commutative law. Either you can perform A plus B or you can perform B plus A, that will give you the same result. Next one is associative law. That is also important for airport authority exam, because they will ask you that your matrix addition is commutative in nature, associative in nature, like that. So it will follow the associative law. Associative law means when you first perform A plus B, then you do the addition with C, it will give you the result, same result. When you first perform B plus C, then you add them with A. So that's why it is associative in nature. Existence of additive identity. Additive identity means what? That you have a matrix and you add something into that A matrix, that will result you the same A matrix. So there is only one zero matrix of same order, that is additive identity. It means if you add the null matrix of same order, that order of your matrix A, then it will give you the same value, that is A, right? So that's why it is called as additive identity. So additive identity of a matrix is zero matrix or null matrix of same order. Remember the statement, same order. Existence of additive inverse. Additive inverse means when you add something to a matrix, that will result the zero value. The additive inverse is minus of A, right? Cancellation law, whenever you have A plus B and A plus C, then it means that B plus C should be equals to BC. So this is called as cancellation law, right? It is true for that one, right? Okay, next. Subtraction of two matrices. When you are subtracting two matrices A and B, right? Subtraction again perform only on the same order matrices. Whenever you have different order matrices, you can't perform the subtraction. And when you find that these two matrices are same order, then you have to perform the subtraction. Subtraction is performed like that. I am taking 1, 2, 3, 4, and this is your A matrix, and we will have the B matrix, that is 3, 4, 8, 9, and we are performing A minus B. The A minus B can be performed by element. That means 1 minus 3, that is minus 2. This is 2 minus 4, that is again minus 2. 3 minus 8, that is minus 5. 4 minus 9, that is again minus 5. So this is your A minus B. So how we can do that? I am again repeating the step. Whenever you are performing the subtraction, first you have to perform A minus B. Sorry, first you have to check that both A and B are of same order. When you check that the both A and B are the same order, then you have to do A minus B element by element. You have to subtract the Aij minus Bij of the A and B of M cross N, right? Okay. That is multiplication of a matrix by a scalar. It is important, right? Whenever you have a matrix A, let us take you have a matrix A, that is M cross N, and you multiply this matrix A with a constant. So what is happening? Each element of this Aij will multiply with that constant, right? Each element. In case of determinant, that is different. Remember, this is the property different in case of when we talk about the determinant, right? Here, if you have a matrix and you multiply this A matrix with a constant, then each element of this matrix will multiply with the constant. Let's say you have again 1, 2, 3, 4, right? We have a matrix A and I multiply this matrix by 2A, a constant value. Then the first element become 2, second element become 4, third element becomes 6 and fourth element become 8. So all the elements of A matrix will multiply with this constant, right? Properties of scalar multiplication of two matrices A and B. Right, whenever you do the scalar multiplication, see the first property is K times A plus B. That means you can do first multiply the A with K, then multiply the B with K, and what you got the result, then you add that together, it will result the same value which you got from this side. So that means this is follow this relation. Then when you perform K1 plus K2 times A, that should be equals to K1A, K2A. K1, K2A, that is K1 times K2A or K2 times K1A. If you multiply minus K times A, that will be equals to minus Ka or K times minus A. So these are the properties of your scalar multiplication. Now the next thing, that is the important thing, right? That is matrix multiplication, and this is most important. I think what we studied today, definitely you will get one question from this one in your inside your airport authority exam. Let's A is equals to Aij, and that is M cross N, and again you have B is equals to Bij, that is N cross P. So basically to perform A into B, let me tell you. The first thing, we have A matrix M cross N and you have B P cross Q. Try to understand here. We have two matrices, A matrix is M cross N, B matrix is P cross Q. So basically if you are performing A into B, then to exist this A into B, or to perform this A into B, this N should be equals to this P. The first thing, this N should be equals to P. So N is always equals to P to perform A into B. So if you want to perform A into B, then M is always equals to P, and the resultant matrix C, which we will get, that is M cross Q. So whenever you are performing A into B, A is M cross N, B is P cross Q, then if you are performing A into B, then N should be equals to P, and when your N is equals to P, when you perform that multiplication of A into B, the resultant matrix C must be of the order M into Q. So that is the main thing, okay. And this Cij matrix is equals to this one. We are going to discuss that thing. See, basically if you are performing the multiplication of two matrix 1, 2, 3, 4, that is 2 cross 2, and let's take I have another matrix B, that is 1 and 2, 2 cross 1. So I want to perform A into B. I want to perform A into B. So whenever you are having these two matrices, first you have to check that this value is equals to this one or not. When you check this, that this value is equals to that value, now you have to perform the matrix multiplication. How we can do that? So take this first element, take this first row, multiply this first row with this first column, right? So it means that first element multiply with first element, then plus second element multiply with second element. Now go for the second row because there is no other column. So go for the second row, multiply like this. So 3 into 1 plus 4 into 2. So what we will left, that is the first element is 5, second element is 11. So the final matrix is of the order 2 cross 1. You can check. This 2 is eliminated. We will left with 2 cross 1. So that is the matrix multiplication. And I think you understand how we can do the matrix multiplication, right? Whenever you are doing the matrix multiplication, just remember the number of columns of the first matrix should be equals to the number of rows of the second matrix, right? Okay. It is not necessary, another thing, it is not necessary that if you are performing A into B, the B into A is also be performed, or you can say B into A is also exist, right? Or they can't be equal. It's like if I perform A into B here, that is possible. Is it possible to perform A into B? No, that is not possible to perform A into B, because the number of columns, number of columns in B are 1, number of rows in A are 2, that are not equal. So that is the main important property, right? Commutative law. Generally it is not follow the commutative law. Whenever we are discussing about the matrix multiplication, it does not follow the commutative law, because A into B does not equals to B into A. Maybe in any case it will be possible, but not for all cases, right? Associative law, yeah, it will follow the associative law. When you perform A into B, then you multiply that one with C, it should be equals to, when you perform BC first, then you can do A multiplication after that, right? Existence of multiplicative identity, yeah. Multiplicative identity, again, when you multiply a matrix A with any matrix B, and that will result through the same matrix A, that is called, B matrix is called as multiplicative identity. And here only identity matrix will represent that multiplicative identity. Next one is distributive law. It will also follow the distributive law. If you are performing A into B plus C, that is equals to A into B plus A into C. Cancellation law. If A is a non-singular matrix, yeah, this is important. A is a non-singular matrix, then A into B is equals to A into C, then only B is equals to C. Otherwise, this cancellation law is not applicable for singular matrices. A into B is equals to A into B is equals to 0. It is not necessarily implies that either A equals to 0, B equals to 0, or and both A and B equals to 0, right? It is not always implies that thing, right? Remember, let's take 1 0 0 0, and I have a matrix A, right? This is the matrix A. It is not a 0 matrix, right? Let's take, we have a B matrix that is having element 0 1 0 0, right? So yeah, when you perform A into B, so that will result, you have to multiply this one with this one. So that is 1 into 0, 0 into 1, that is going to be 0. When you perform this one with this one, that is 0. This one with this one, that is 0. This one with this one, that is 0. So here both A and B are non-zero matrix. This is asked in the airport authority exam. Both A and B are non-zero. Both A and B are non-zero, and their resultant matrix of A and B is 0. That is the meaning of this statement. This is very important. Very, very important, right? So remember, whenever you performing A into B, it is given to you that A into B is equals to 0. It is not necessarily implies that A is 0 or B is 0 or both are 0. If A and B both are non-zero, their multiplication results to the zero matrix also. So that is all about this matrix multiplication. So these questions which may ask in airport authority and past exam, they ask, I already discussed with you. Just follow these things, right? It is most important topic, matrix, right? It is again, I'm again saying it is most important topic, and this theory part is mostly he will ask you from the matrix addition, subtraction, and that one. There are more types of matrices are there, symmetric matrices, like skew Hermitian matrices, right? And he may ask you that asymptote matrices, like that, the terms which he is using, right? So you go through that one, and this is most important topic. And if you want to prepare for your airport authority exam, right? Our classes are going on, right? You may join that one. We are currently studying this matrix topic in that classes, in that classes in more depth from here. Here I'm discussing only these things because there is a time limitation. I can't do everything here in time bounded. I can discuss only these things, but in classes I'm discussing everything in detail. So you may join YourPedia for more for classes, right, and to start preparing for your exam of airport authority. Thank you.